SCD operates 24 hours per day, 365 days each year, and is in fact perhaps the largest and most sophisticated atmospheric computing facility found anywhere in the world. Now let us begin our tour. The Cray YMP-8864 was installed at NCAR in May 1990. It contains 8 parallel processors capable of performing over 1 billion floating-point calculations per second. The input-output system, IOS, and the solid-state storage device, SSD, are contained in the 2 wings, which make up the YMP-8's configuration. The SSD provides 256 million 64-bit words of electronic storage, similar to random access memory, or RAM. The input-output subsystem controls the flow of data moving back and forth between the YMP-8 mainframe and the other computer systems elsewhere in the room. The YMP-2D-216 was installed in June 1991. The YMP-2D, supported by the Model Evaluation Consortium for Climate Assessment, or MECA, is devoted entirely to climate modeling research. It contains 2 processors and 16 million words of random access memory, RAM. The iOS and SSD are contained in the wedge, which is located near the mainframe. The YMP-2D performs between 1/2 and 1 billion floating-point calculations per second. Disk storage for the YMP-8 is provided by 16 DD49 disk drives, each storing 1.2 gigabytes of data, and 8 DD40 disk drives, each storing 5.2 gigabytes of data. The YMP-2D has 4 DD41 disk drives, each storing 4.9 gigabytes of data. To the right of the DD49s is the intermediate disk storage, which consists of 24 IBM 3380 disk storage units, each providing 5 billion bytes of storage for a total of 120 billion bytes of fast access storage. These disk drives are used for temporary intermediate storage of archived data files that are accessed most frequently by SCD's users. The StorageTek 4400 Automated Cartridge System, ACS, a fully automated information storage system, was installed October 1989. Early in 1992, the ACS held approximately 1 terabyte of data. With new equipment, which is expected to be installed by year's end, the storage capacity will increase to 4 terabytes. In the center of the ACS is a freestanding robotic assembly that retrieves, mounts, and demounts 18-track cartridges. The robot is able to retrieve and deliver a cartridge in an average time of 11 seconds. NCAR is a member of the Center for Applied Parallel Processing, or CAP. CAP's connection machine is a massively parallel computer which is manufactured by Thinking Machines Corporation and has 8,192 processors which operate simultaneously on different data items in memory, thus speeding up computation enormously. CAP scientists use the connection machine to solve problems in areas such as oceanography, climate modeling, turbulence, computer vision, and genetic coding. The connection machine is also being used by the Scientific Computing Division to benchmark the growth of parallel processors for future development. In this area of the computer room is the Gandalf Port Contention Device, or PAX, which is in effect a sophisticated switchboard that can handle up to 1,000 incoming and outgoing calls at once. The PAX provides links to a variety of systems for interactive and batch jobs that are lined up waiting for access. By using satellite dishes like this one here at NCAR, researchers at remote sites can access data or submit jobs to the NCAR computing system. NCAR also has a place or is a node on a national system called the National Science Foundation Network Backbone, which links all the NSF-funded supercomputing centers. Through the technologies of communications, local area networks, wide area networks, network gateways, user workstations, and window interfaces, SCD assimilates the user nodes into an integrated environment with the mainframes and network servers of the computing facility. The Scientific Computing Division is responsible for the operation of many Unix-based servers and workstations, the majority of which are Sun systems of various types. These computers are used by the SCD staff and users for program development, computer documentation, file servers, and communication gateways. This section of the computer room is the console area. Here, operators monitor all of the computer hardware. These consoles alert the operators to bottlenecks that could slow down traffic on the network and to erratically performing programs, as well as computers having hardware failures. The consoles also inform the operators when tapes need to be mounted. Our peripheral read-write devices consist of half-inch tape drives, cartridge systems, and 8mm video cassette drives. The console operators control the restart procedures when it's necessary to bring a device back up after it's been shut down for maintenance or after an equipment failure. IBM 3490 and StorageTek 4480 dual data cartridge storage systems provide 12 cartridge drives for intermediate and archival storage. These drives require that cartridges be mounted manually by the operations staff. A tape cartridge holds more than twice the data of a half-inch 2,400-foot magnetic tape reel. Its smaller size and faster data access speed make it preferable. As of June 1992, 26 terabytes of data reside on approximately 100,000 of these cartridges. The IBM 3090 controls the IBM 3490 tape cartridge system, the IBM 3380 disk farm, the IBM 3420 tape drives, the StorageTek 4480 cartridge system, StorageTek 4400 automatic cartridge system, 2 Xerox 4050 laser printers, and 8mm video cassette drives. SCD also supports the production of 16mm movie film from the data the computers produce. The old saying, "A picture is worth 1,000 words," is very true, but animation provides even more information. Scientists can easily take this portable data with them when they give seminars or travel to other research institutions. Many jobs utilize SCD's graphics output capabilities. In fact, the SCD graphics output group processes over 100 billion bits of data, resulting in the production of 900,000 frames of film per month. During 1992, in response to changing user demands, videotape became available as an additional output medium, giving local and remote scientists the ability to produce high-quality animation simply and effectively. Initial formats include VHS, Super VHS, 3/4-inch U-matic, and 3/4-inch U-matic SP. Additional formats will become available dictated by user demand. The floor of the computer room is carpeted with special anti-static carpet tiles, allowing the normal static charge of the human body to discharge into the floor rather than into the equipment. This prevents accidental damage to the sensitive circuitry within the computers. The floor is also elevated about 26 inches above the concrete underfloor. The elevated floor allows room for intricate and complex wiring for the various computer systems, as well as directing the cool air supply to the computer systems. The computer room must be kept at 68 degrees Fahrenheit plus or minus 5 degrees, and at 45% relative humidity to ensure proper operation of the computer systems. This view shows the console, which monitors various environmental concerns such as temperature and humidity. It also monitors fire alarm status. When any of these parameters are out of bounds, an alarm sounds, calling the operation staff to immediate action. Many motors and blowers in the room make for a slightly noisier and cooler environment than most people are accustomed to. Large motor generators convert 60 Hz power to the 400 Hz power required by the Cray supercomputers and their disk controllers. The entire Cray system, including all peripherals, requires 347 kilowatts of 400 Hz power and 83 kilowatts of 208 and 120-volt 60 Hz power per hour. Computers demand a constant flow of clean electrical power. Any sudden drop, surge, or slow reduction or brownout of power can be damaging to the computer equipment. To help prevent this damage to equipment and interruption of service to our users, most of the communication system's small and medium-scale equipment is hooked to a battery-powered uninterruptible power supply, UPS. When needed, this battery system can supply power to the equipment for approximately 15 minutes. If the power problem has not been resolved by this time, operators are able to shut down the equipment in an orderly manner. This video was produced in the spring of 1992. Remember that computing technology is being improved and updated constantly. We hope you've enjoyed this tour of the Scientific Computing Division at NCAR.